subtraction problems and try to explain today with pictures when you borrow and what that means. That's what we're going to do today. I saw a couple hands up. Chris?
Do we need to write this down?
What I would say is don't write this down at first, just watch, and then I'll have lots of examples for you to write down, okay, or 3 or 4, okay. So we have 2 subtraction problems here, one on the left, we'll call that number 1, and then one on the right, number 2. And on the first problem, I want to show you how to, we're going to look at the picture, and we're going to build this problem with a picture, and then do the subtraction. And it kind of reminds us why we do common denominators. And we're going to do the second problem like that. And in the second problem, you're going to see that it works a little bit different, so we have to do some borrowing. Okay? So first of all, this first problem says you have 2 and 5 6. So what I'm doing now is I'm going to build 2 and 5 6. I learned this really neat thing today with the smartboard. Watch what I can do. I can take this shape and I can divide it into 6 parts. Is that cool?
You divide it to like a lot.
Yeah, but I only want to divide it into 6. So now I'm going to just move that because I want to have 2 and 5 6 in my picture because I have 2 and 5 6 in my problem. Isn't that neat? And I want to subtract out 1 2/3. But you guys know that from the last couple weeks, 2/3. Oh, you just missed the coolest thing that I learned. You'll have to stay for a minute. Okay, so you guys know from the last week that I need a common denominator here, right? So what's going to be, Chris? What's my common denominator?
Oh, for 3 and 6, I think it's 6.
Yeah, it is 6. So Armando, I have to multiply this and this by what to get that denominator?
By 2.
By 2. So 3 times 2 is, sorry, no, we did 3 times 6.
Oh.
3 times 2 is 6, and 2 times 2 is 4, right? So now, this is the same as taking 2 and 5 6. I'm going to rewrite it. And I'm going to subtract 1 and 2 and 4 6 instead. Because 2/3 is the same as 4 6. Does that make sense?
Yes.
So when I subtract that, I can take away 4 6. So Izzy, what do I have left in the picture? 1 6, right? So over here, you're right, you have 1 6. And now I have to take away 1 whole. So I have to take away 1, which is 1 whole. Okay? Does that make sense? That's kind of review, right?
Because you were taking off the 2.
Because I was taking off of the 2. Right. Off of the picture and in the problem. Okay? So watch over here. Now it's a little different. So on this one, I have 3. And I have to make this into what? 1/3, right? So I'm going to divide this and get rid of those because I only want thirds. Whoops. Isn't that cool? Didn't go. Okay. So now I have 3 1/3. Okay? Here's the problem. How many wholes do I have to take away? 2, right? So I could do that. I'll just pick my way over here. But Larissa, how many thirds do I have to take away? And I only have 1. I could take 1 from here, right? That's called borrowing. So I'm going to split my shape again. That's exactly right. Into thirds, right? And then I could take 1, 2 away, and so without actually doing a lot of pencil and paper work, you could tell your answer is what? 2 what? 2/3. Okay, the problem is you can't draw pictures all the time of everything, so you have to learn how to do this without a picture. Okay? That's what we're going to work on. So I'm going to bring in another page. We're going to look at both of them at the same time. And And I'm going to try to explain how this works with the picture, but also with using a paper and a pencil. So I'm going to take my original problem, 3 1/3, subtract 2 2/3. Okay? So I'm going to get my problem all built up again. And let's just do this. There's 3 1/3, right? So do you remember that when I do this, when I look at a problem here, I'm trying to take 2/3 from 1/3. So Andy, what was the problem here?
There wasn't enough pieces.
Right, there wasn't enough pieces. So in the picture, I divided it into how many parts, Andy?
3.
3, okay. So in the problem, the way, this is, Chris, you were asking about writing things down. In a minute, you're going to write this example down. So you might want to watch it, but I'll let you copy it down. In the problem, I changed my 3 holes to 2 holes. So I put a 2 there. Okay? Does that make sense? So Izzy, stay with me. See, I took my 3 holes and I changed it to 2 holes, right? And then I took that other hole and I made it into what, Armando? How many pieces are here?
3.
So 3, and there's third size. So you add them in the math. You add them here. So what's 1/3 plus 3/3? It is, but I want to think of it, it's like wearing a costume. It's like a hole in costume. Okay, you want it to look different because you could say this is just 3 1/3, or we could say it's 2 and how many thirds?
7.
Okay, 4/3. So look at, Larissa, I'm adding 3/3 to 1/3, so I make it look different here, just like I make it look different in the picture. Okay? Now, I can bring this over, and because this number, the number on the bottom is smaller than the number on the top, now I can do subtraction. So, Chris, when I subtract 4/3 and I take away 2/3, what do I end up with?
2, so 4.
So I took 4/3, right? And I took out 2/3. How many thirds do I have left? 2. But you still have thirds, actually. It's 2/3. And now I'm going to take the 2 holes and take 2 holes away from it. So what happens there? Well, if I take 2 take away 2, what do you get? 0, right? So you just leave it, because when you take those away, they're gone. Oh, that one doesn't, it's infinite cloned. We have to do this. Okay, so you're only left with 2/3. That's borrowing. Okay, so we're going to practice that. Raise your hand if you get kind of the idea, just the idea, Mr. Bell says. Okay, James, good? All right. How are you guys doing on that other assignment? Okay. They're doing some book 7th grade. You? Okay, so let's try this problem with borrowing. Write this example down. Now you want to write an example down. So copy the problem. Copy the top one first. And then try it. Let's try the top one. How come I'm recording it? So I can put it on that YouTube channel. Okay?
So you better be smart.
So let's copy it and we'll talk about it in a minute. Start again. Okay, so we're going to do this problem. First check to see if we have a common denominator. So Andy, do we have a common denominator?
Yes.
Good. So then you check to see if you need to borrow. So you're going to look at the number in the bottom and say, can I take 2 from 1?
No. Yes.
You can? Can I take 2/3 from 1/3?
Oh, no.
No, right? If I only have 1/3, I can't take 2/3 away. So let's think about that picture again. It helps to think about the picture. So if I put in my 7 circles, I'm just going to make them a little bit smaller, and I'll put them up here. So 5, 6, 7 circles, and then I need a third, right?
Yeah.
So I'll split this
I want
into,
to put another hole because one of them are closed.
well, I'm going to, yes, I'm going to make this, I'm not quite done making this, right? So now I have 7 and a third. Do you see that? Okay, and so if I wanted to try to take away 4, that I would be able to take these 4 away, right? But I can't take away 2/3 from here. See the problem? You guys see that? That's why you have to borrow. And in the numbers, what it looks like is when this number down here is bigger than this number up here, you have to borrow. You have to change that 7 to 6. And then instead, you're going to make this into thirds. So instead of 7, you have 6, but you have to remember to add in those thirds. So instead of 7 and 1/3, we have 6 and 1, 2, 3, 4 thirds. Does that make sense? Yeah? Did you get that? Okay. Armando?
Wouldn't it be 6 and 4, 6?
It'd be, no, because you don't have the denominators.
Oh, yeah, that's right.
So then you subtract 4 and 2/3, and you get 4/3 take away 2/3, which is 2/3. That's right. So in other words, 4/3 we can take away 2/3, and then we have to do 6 take away 4 wholes.
Oh, sorry.
So we're taking away 4 wholes, and then Shiloh, what am I left with when I do 6 take away 4? 2, right? So here's 1, 2, and here are the 2/3. So my answer is 2 and 2/3. How are we doing on that?
Good.
Okay, let's have you try one yourself. Okay? Let's try this one. It's another subtraction problem.
How come you
So-
do multiplication on those?
Well, we're not ready to do multiplication yet, so copy that down and let's try it. Okay, so let's do this one. We're gonna try without a picture this time. So we have a common denominator, so that's good. But what's the problem here, Larissa? Do I have to borrow? How come?
Oh, yeah, you could have
Because you can't take 6 from 5, right? So Armando, how do I show borrowing? What's my first step?
On which one?
On this one, what do I do? Look at your notes, we just did one. What did I do up here? What was the first thing I did?
Multiply. No, you add.
Not quite. Chris, you want to help?
You took away 1 from the 7 on the top.
Right, up here I took away 1 from the 7.
Yeah.
Oh yeah, it turns into 3 then.
So thank you for helping, Chris. That's right. So now Armando can start. So you're going to take away 4, 1 from 4, and it turns into a 3. And then we're going to add 7 sevens here. Okay? You always add a fraction with the same numerator and denominator as the denominator in the original problem.
That got kind of confusing, but I got it.
Yeah, that's why we have to practice them. So now we have 3 wholes, and what's 5 plus 7? Yep. 12, that's right. So 12 sevens. So now we have 3 and 12 sevens. It doesn't matter if it's the middle of the problem, because the middle of the problem, look, back up here, it was improper up here. That actually helps us solve the problem. You just don't want to leave your final answer.
So,
This was improper, right? You just don't want to leave your final answer improper.
so if if the 4 turns into a 3, to a 3, does that mean the 2 turns into
No, because you only borrow with the top part. So now I'm just gonna move that 2 and 6/7 over, and I'm gonna subtract, because now I can say 12 sevenths take away 6 sevenths. What's
6.
12 take, yeah, exactly, 6 sevenths. And now 3 take away 2 is
1?
1, and that's my final answer.
That's kind of easy and weird.
Yeah, it's not that bad. Okay,
Wait,
so copy that down. So on this problem, this is a different problem. It's a little harder because what do you notice right away about the denominators?
that
They're different. So before you ever talk about borrowing, you have to get a common denominator. You have to do the old stuff. So it becomes more steps. Do you know what the denominator is, Chris?
No, but I want to try it.
Okay. So what's the common denominator going to be? What do you think? So, you could use the ladder idea.
It's 30. No, it's 15.
It is 15. You want to explain how you did that?
No, that's what I said.
Oh, you said 15?
Like in the 5.
In the 5s. Right, so you could use a list, 5, 10, 15, 20, and go by 3, 6. This is kind of a long way, 9, 12, 15. And the first thing that's common is 15. Or you could use a ladder. Do you like the ladder? James?
Well, what I do sometimes is I'll multiply the two denominators.
Which works great when the numbers are small, but sometimes when the numbers are big, you want to get the smallest common denominator. So that works. And that works great here. And we'll go with that. The only caution is when the numbers get bigger, you might have some reducing to do. But here it works great. Let's do it. So multiply 3 times 5 and 2 times 5. So this becomes 1 and 10 fifteenths. How about up here? I have to multiply by
The same thing that you did.
times by 3, right? To get 15.
That would be 6.
That would be
No, that would be 9.
9 and 15, right?
Yes.
So this is 4 and 9 fifteenths. Okay? So that's review. Now I have 10 and it's bigger than 9. So this number is bigger than this number.
So
That's when you borrow. So I have to change the top. How am I going to do it?
Turn into a 3.
It's going to turn into 3. Perfect. And then I'm going to have to add here 15 fifteenths. So I get 3. Andy, you should be writing this down. Right? These are your notes. What's 9 and 15 when you add those? Good. That's good. 24. So 3 and 24 fifteenths. And then take away 1 and 10 fifteenths. Okay? So 24 is bigger than 10, so now I can subtract. So what's 24 take away 10? James? Yeah, 14. Whoops. Can you read that? And then when I subtract 3 take away 1, I get 2. So you guys, in the beginning of the class, what the other half of the class did was that for a warm-up. You just did that problem. Okay. So that's pretty good. Let's try one more practice problem, but I think I'm going to stop this. That's enough for this. Okay.